Hello and welcome to the Mindful Inquisitor. Here we discuss all things related to the science and health benefits of mindfulness meditation. I am your host, Sydney, and if this is something that interests you, please feel free to subscribe and stay tuned for further episodes. There are multiple angles at which one can analyze changes in the brain given various conditions. Researchers can observe changes in neurochemistry, which is detecting the concentrations or the changes in concentrations of various neurotransmitters. Or one can observe the way brain sizes change in certain areas. Here, I will explore both avenues. From a neurochemistry point of view, the relationship from changes caused by meditation in the autonomic nervous system and parasympathetic activity is obvious. In a meta-analysis review of neurobiology studies regarding mindfulness meditation by Esch in 2014, a general consensus was noted that within meditators there is an increased level of dopamine and melatonin, and a lower level of norepinephrine or noradrenaline, depending on how you like to say it, and cortisol. Now, dopamine is a common neurotransmitter brought up in daily conversation. We think of it as a neurotransmitter involved in general well-being, but of course it plays a vital role in a vast array of healthy bodily functions. Melatonin, of course, is a neurotransmitter involved in healthy sleep patterns. The other two neurotransmitters are common amongst the sympathetic nervous system, which is the fight or flight response, not to be confused with the parasympathetic system, which is involved with the resting. The sympathetic nervous system is the part of the autonomic nervous system that is involved with our stress and threat systems, and in chronic use is indicative of poor health. So, both of these neurotransmitters are the signals for stress in the body and are reduced in meditators. Now, let's look at how the brain changes in shape and size from meditation. There is a common phrase used in the study of neuroscience, the use it or lose it idea. It describes how when neurons are frequently used, they grow in size and send more neurotransmitters, increasing their abundance in the brain. So, when brain areas get bigger, it is indicative that the individual is using that area more. The opposite is true, of course. If you don't use a particular neuron, it may be lost or really repurposed for another area or function in the brain. This is easy to comprehend at times, as we surely have all felt this way with our memories. When you often recall a memory, it becomes easy to recall it again, and that memory becomes very solidified in your conscious mind. However, if you stop thinking about a particular moment, in the future it may become harder to recall that memory again. This is the use it or lose it idea at work. Now, referring back to the meta-analysis paper I talked about earlier, Esch 2014, there is a general observed increase in cortical thickness found in meditators, and for those who don't know, the cortex is the outside area of the brain with all the folds and the tangles that we commonly associate with the brain and what it looks like. And this area is found to increase in meditators. More specifically, areas in the brain that are involved with attention, memory, sensory processing, perception of senses, self-regulation, and regulation of emotion have all been shown to increase in thickness. Most of this makes sense, of course. Mindfulness meditation is a practice of retaining attention of the breath while having a non-judgmental awareness of all thoughts and feelings, meaning we gain practice with self-regulation and emotional regulation, not to mention focusing on the breath and the body as an anchor allows us to practice sensory awareness and processing. And of course, practice, from the brain's point of view, is repetitive use, and with repetitive use, the neurons grow in size and abundance due to the nature of the use it or lose it idea. And when they grow in size and abundance, it becomes easier to do again, making the skills acquired in meditation easier to do in everyday life. I would like to take a moment now to discuss a specific brain area that has been observed to change. More specifically, is the interaction between two specific brain areas. It is involved with our emotional regulation process. This is the interaction between the prefrontal cortex and the amygdala. The prefrontal cortex is the very front of our brain and is involved in higher level thinking and cognition. According to Des Boards and others from 2012, the amygdala is involved in emotional processing, both positive and negative. Additionally, according to Taryn and others from 2015, the amygdala is also involved in perceived stress. Now, one job of the prefrontal cortex is to regulate and inhibit the amygdala, more specifically, the basolateral amygdala. And this is according to Emil Rosencrans and Grace from 2002. When the prefrontal cortex fails to inhibit the activation of this area, hyperactivity in this area can occur. Those who suffer from depressive disorders have also been shown to have larger basolateral amygdalas after death, and this is from a study Rubino and others from 2016, suggesting that the inability of the prefrontal cortex to inhibit this area is indicative of the manifestation of depressive symptoms. An fMRI study found that mindfulness is correlated with increased prefrontal cortex activation and decreased amygdala activation. This is Cresswell and others from 2007. Additionally, a study that monitored those who keep attention to the breath observed synchrony between the amygdala and the prefrontal cortex. This is Dahl and others from 2016. Both of these studies provide strong evidence that mindfulness meditation strengthens the connection between these two areas and allows for prefrontal cortex to properly inhibit and regulate the amygdala, translating into greater emotional regulation amongst individuals. All of this information to me is incredibly fascinating and surely shows that mindfulness meditation generates real physiologic changes within the body. However, in science, simply observing correlations between two things like meditation and brain changes isn't enough. One must also be able to tease out the causal mechanisms to how these changes occur. This is something that is very new within the scientific research realm of mindfulness meditation and is certainly not well understood. However, in my next few talks, I will attempt to provide some possible mechanisms of how these changes occur while using scientific research to support my arguments. If you are listening to this video through a podcast, please see my YouTube videos and channel to gain access to all of the citations for the papers I have been referencing throughout this talk. I also have a Patreon, so if you like these talks and would like to see them continue, please contribute there. I would deeply appreciate it. Lastly, if you enjoyed this, please subscribe and leave a comment if you feel it is right. Until next time, peace.